This is the most technologically advanced, highest capacity, highest revenue generating IC wafer foundry in the world, Taiwan's Semiconductor Manufacturing Company, TSMC. TSMC revenues topped $15 billion in 2012, but few know that TSMC's first plant, opened in 1986, was a 6-inch VLSI wafer fabrication facility designed and transferred by the Industrial Technology Research Institute. To understand the genesis of TSMC, we must return to February 1974, to a history-making meeting at Taipei's Xiaoxinxin breakfast shop on Huaining Street. The 7 attendees included Director of R&D at RCA, Wenyuan Pan, Minister of Economic Affairs, Yunxuan Sun, Minister of Transportation and Communications, Henry Yushu Gao, Head of the Directorate General of Telecommunications, Xian Qifang, Executive Yuan Secretary General Hua Fei, Telecommunications Laboratories President Bao Huangkang, and then ITRI President Zhao Zhen Wang. Their 2 to 3 hour meeting concluded with a breakfast bill of $400 NT and planted the first seeds of Taiwan's future semiconductor industry. The central figure at that meeting in terms of technology was RCA's R&D Director Wenyuan Pan.
潘文渊先生是在中国的交通大学毕业的，后来到美国去念书，到斯坦福大学。潘先生就变成在海外这些华人的知识跟台湾交流的一个关键点。
Wenyuan Pan viewed Taiwan's labor-intensive, export-oriented electronics industry as delivering only slow economic growth. The time, he said, was ripe for transformation. He proposed at that 1974 breakfast meeting a new strategic focus on integrated circuits to enhance the overall competitiveness of Taiwan's electronics industry. He suggested licensing foreign technology directly to speed up the transformation process.
那孙部长就说：“那你来写这个 proposal。”所以他就只好关在那个，听说是关在圆山写了2个礼拜。
Wenyuan Pan was enthusiastic about this new venture. Committed to helping his homeland, he took early retirement from RCA and invited other US-based overseas Chinese with IC expertise to join the new venture.
那时候潘文渊先生在圆山大饭店，那时候我就打电话，我说假如说找人有困难的话，我们一边找，但这个案子要进行，所以就我来负责一部分工作。在那时候来讲的话，也有一种年轻人的当仁不让的一个想法。
Wenyuan Pan and Dinghua Hu, then chairman of NCTU's Electronics Engineering Department, shared strong ties to Jiaotong University. Hu's participation marked the first of many right people at the right time moments in the exciting story of ITRI. To move the nascent integrated circuit program forward, ITRI officially established the new Electronics Industry Research Center on September 1st, 1974, with former Telecommunications Laboratories President Bao Huangkang as president and Dinghua Hu serving as vice president.
经过广泛的讨论之后，他们就觉得放在刚刚成立的工业技术研究院可能最恰当，因为最重要的事情是人才。
On October 26th of that same year, Minister of Economic Affairs Mr. Yunxuan Sun's visit to the United States and a banquet at Wenyuan's home succeeded in signing up overseas Chinese intellectuals, the founding members of ITRI's Technical Advisory Committee.
这可能也是一个在当时来讲最完美做法，由资深的人做技术的指导跟顾问，然后愿意这个努力的年轻人去做执行。
Bing He Yang, Qin Tai-shi, and Qingju Zhang, all Taiwan students studying in the U.S., picked up quickly on Taiwan's decision to dive into the deep end of the IC sector.
那我是在 Princeton 的电机系同学里面呢，就像张清居啊，像这个杨丁元啊，这是我们比较在一起的，是在同一个电机实验室里面的。 台湾区的学生，所以我们闲着无聊嘛，常常聊天，在一起谈啊天下大事啊什么。所以那个时候呢，是一个钓鱼台的事件，是在70年代的时候。那么因此就谈到最后就会谈到说，那我们以一个留学生跟我们那个时候的能力，到底我们可以做什么？就是因为这样，我们从中央日报里面就看到说，台湾呢有意要发展一个什么半导体的实验室，因为是我们的专业，所以我们看了之后就觉得，那也许我们应该要去多了解一下。
我就写信回来说，愿闻其详。所以他们这个信里面就是说，请我们跟这个当地的潘文渊博士跟刚好在 Princeton 有一个罗无念的教授联系。他说这2位先生都是顾问。我说居然就在附近，所以就跟潘文渊跟罗无念联系上了。那时候我们快毕业的时候，去跟他们请教说当时候的进度怎么样。他说还有一段时间，那么希望我们先去做事情。所以我们在这种建议里面，就是去找到事情，在南部的佛罗里达找到一个事情，那么在那边工作，那么保持跟他们联系。
In December 1975, Bing-Her Yang left his position with Harris Semiconductor to return to work in Taiwan. Qin Tai-shi and Qin Ju-zhang followed in Yang's footsteps 3 months later.
那一回来台湾，我马上直接就到工研院来了。新竹在那个时候算是相当乡下的一个地方，然后当然从国外回来，这待遇也差很多啊。
对，那么那时候是台币40块比1块钱美金，所以这个在收入的损失上是很多了。
但是因为有一个对未来觉得说，可能是要做一个蛮重要的工作。
我觉得这个好像是个历史性的一个工作，所以我就决定要回来。
Apart from talent recruited from overseas, about 40 exceptionally talented domestic technicians were transferred in from Taiwan's telecommunications lab and recruited from major companies such as FPMC, Microchip Technology Corporation, and Texas Instruments. They became Taiwan's IC technology pioneers. The complexities of integrated circuit technology and funding limitations meant that ITRI would choose only one of the world's various IC technologies to introduce and further develop in Taiwan.
台湾是一个海岛国家，在经济初期要发展、要起飞，外贸靠出口，我觉得是没有其他的选择。在这个的状况之下来讲的话，应该是以消费电子是一个长期发展的路径。在当时，假如从技术的观点来看的话 ，CMOS 是最适合消费电子长期多层次的发展。
In the end, a decision was made to forge a technology transfer relationship with RCA.
我们当时的构思就是希望它跟台湾不是第一次往来，然后跟我们政府、这个民间等等都已经有很多的这个接触了。这样子的话，履约的可能性会比较高。那么第二点 ，RCA 是最早发展 CMOS 技术的。第三个考量是 ，RCA 是唯一愿意帮我们训练10个设计工程师。
Next, Bing-Her Yang and Qin Tai-shi brought in new recruits for the government-sponsored training.
那么到了好像第2年的4、5月就开始出发，当初就组织了4个 team。那我是到 New Jersey Somerville 去负责这个 design。那史信泰先生就到了 Ohio 去，那边有工厂，那么他们所有做制程的人跟生产管理都到 Ohio 去。那么另外有一个 team 又在 New Jersey 做 testing， 是张进居先生。那么另外一个 team 是在佛罗里达，那么另外一个厂那是许健在带队。
To abbreviate the domestic learning curve and quickly validate transferred RCA technology by actual design and commercial production, Dinghua Hu began concurrent construction of the nation's first demonstration IC production facility in July 1976.
当时这个计划非常难得的是什么呢？我们固然没有非常有经验的人，但是我们真的有非常这个棒的年轻的人。比如说建厂吧，我找了一个是成大土木毕业的张路满。
好，吴天华先生进来以后呢，那我们就是开始才想，我们要做的像 CMOS 啊，就做 CMOS 以后呢，那个观念才开始带说什么无尘室啊，因为他是计划主持人嘛，他把这个东西是等于是他生命一样，等于他小孩一样啊。
我们希望这是第一个厂，不是我们最后一个厂。所以换句话说，这个建厂的技术也要能够在台湾开始起步。
Today, ITRI Building 15 is the designation used for Taiwan's first demonstration IC production facility.
很高兴的看到这个东西40年后它还在这里，对不对？
依然存在，
依然存在，而且还在生产。这是我想我们值得骄傲的地方。他的牺牲赛最大，因为他从开始一直留到现在。
目前这栋也是因为当初是示范工厂第一次先做的，配合这个需要，又做了几次，刚才讲也差不多历经3次的 remodel 过。
对，那个时候最重要，我是觉得说会成功最重要说，那个我们的目标非常清楚，我们看到说我们就是要建这个厂，我们台湾要靠这个厂翻身。
RCA technology transfer was done based on a clear blueprint with clear goals. Those trainees who went to the U.S. took with them purpose, ambition, and a passion for learning. They absorbed essential design, production, testing, and maintenance skills from their RCA technician trainers. They returned to Taiwan after completing 6 months to 1 year of training. Taiwan's first demonstration IC facility officially opened on October 29, 1977. Taiwan's RCA-trained staff applied their newly learned skills to begin a pilot-run production of IC chips for digital watches.
我记得我们这个出来的第一批，就是它是成功的产品，这个是非常困难的，所以当时真的是非常的兴奋啊。
那么我们也很庆幸这个潘文渊潘顾问 TAC 的 member 很快的跟这个电子中心这边达成了这个共识，我们把一个这个场所的厂改成了工厂的厂，也因为这样子的话，它是一个在量方面、产能方面增加了好多倍。
But market doubts about product viability led to few business inquiries. Qin Taishi reflects on those times.
结果有一天呢，就是有人介绍说，香港有一个做表的人啊，是台湾的侨生，说他也想要来看看参观，所以他们就参观，他就觉得，这个还蛮先进的哈。后来发现呢，原来那时候的厂长啊，我跟他是同寝室的同学，就在台大的时候啊，所以他就说，老史，我知道啊，他做应该没有问题啊，我就下个单吧。所以他就下了第一个单子，10万颗。
This promising start opened the way to smooth sales growth. 6 months after opening, yield at the plant was higher than RCA's. The facility was an important supplier to digital watchmakers around the region. Work began in earnest to design other consumer product IC chips, including IC chips for remote-controlled toys, melody cards, push-button phone panels, and more. Chips were shipped directly to manufacturers in Taiwan and Hong Kong. But the plant's exceptional yield rate led the original provider of the technology, RCA, to submit a proposal to the MOEA to buy out the demonstration plant. Qin Taishi reflects back on events that nearly snuffed Taiwan's future IC prospects.
RCA 来做 proposal 的时候，我是跟着方贤启方院长去经济部听这个 proposal 的啊，所以听完了之后回程的路上， 是方院长跟我邀请我坐在他的车上，所以我是一路上跟他来分析，然后表达说，如果是这样的话，我就不做了。
Luckily, at the critical moment, ITRI held its ground on the necessity of a domestic IC production industry to support Taiwan's competitiveness in electronics. It set the stage for Taiwan's current leadership in semiconductors. This was the watershed, the point when impassioned young talent focused their intellect and energies to open a door onto Taiwan's high-tech future. Starting from nothing, their contributions made Taiwan the third largest exporter of digital watches. Collectively, they shared a willingness to sacrifice the self for a greater good. That is to say, starting from nothing, they built the foundation of Taiwan's semiconductor industry.
所以后来王先吉先生他也就讲，他说那个时候幸好我们这些年轻人都不服输，告诉他我们不应该这样做，否则后来的发展就没有了。
The demonstration IC plant successfully launched Taiwan's IC industry and helped move Taiwan from labor-intensive to technology-intensive production. But, apart from R&D, ITRI's mission included stimulating industrial development and creating new economic value. Thus, from the very beginning, ITRI's plan was to step back from production. Technology from successful projects was transferred to the private sector.
那当然要移转最简单就是说我把现有东西给你，将来你竞争行不行是你的事。可是我们觉得是这样的话，大概看起来一定不会太会成功，所以我们其实蛮大胆的啊，很多人都不太敢做啊。所以我们是不是能够预测未来它应该要有这个技术才能够生产，才能够竞争？所以我们虽然没有做过4寸，我们就是决定我们要盖一个工厂，联电的第一厂工厂，要是比工研院现有的技术要前进的东西。
But convincing private investors to finance such a bold move was not easy. Much groundwork had to be done before UMC was finally formed in 1980. UMC was ITRI's first spin-off enterprise.
我想以前台湾也没有人做过，就是一个研究所怎么样能够去帮忙一个企业盖这么大的一个生产设备，所以我们帮他做盖厂规划，帮他怎么整个盖厂啊，设备应该怎么做了哈，包括人员的培训啊，那培训之外还有软体啊，所以我们管理的软体，包括要生产什么呢？哦，所以也把产品也是授权给他去做，然后甚至于有一些人员啊都移转了哈，包括我们重要的一些工程的干部，包括了一些初期的培训的生产线的人员、管理的人员都是这样，所以那时候大概总共应该移转了大概40个人吧。
联华钢材一成立的时候，你找人去啊，就是要找这个主要这个干部去，很多人都不愿意嘛，因为赚不赚钱、成不成功都不知道，工研院稳定嘛。不过也有是勇气十足出去的，像曹新成就是，那时候他去的时候，我还送了他8个字啊，我说成者为王，败者为寇。今天看起来这些决定都是对的。
The success of UMC established Taiwan's model for commercializing new technologies. It gave the nation its first solid step into the semiconductor industry. To further enhance domestic technological capabilities, ITRI completed the country's first experimental 6-inch IC wafer fabrication plant. Then ITRI President Morris Zhang thought the huge investment necessary would generate little practical economic benefit if it was used only for research purposes. Therefore, he raised the idea of transferring the experimental VLSI fab to the private sector as a dedicated IC foundry. It was the beginning of TSMC and the IC foundry model now used worldwide.
当时候有这种所谓的代工都是这样，就我有能量，我分一些给你，所以来接生意。当市场很好的时候，我就做自己的，不做别人的。 所以当你有自己的生意跟你的客户的生意冲突的时候，你去做代工，没有人相信你。所以他当时我们这个定位的出来的就是说，要是一个纯粹的、单纯的、绝对不做自己的产品的一个这样的 model。这个 model 就保障客户的权益。其实这个概念是在学理上是存在的哈，甚至于在美国也是提出来的，只是都没有人要接受它。
Taiwan's human resource advantages led Morris Chang to believe the concept had good prospects for success. He submitted a proposal to the executive yuan to form the Taiwan Semiconductor Manufacturing Corporation, capitalized at 10 billion NT dollars.
那就变成一个很大的一个投资的案子。那不管是国内的投资，或者是国际的投资，都对这个计划呢是抱有不是很乐观的看法哈。
Morris Chang's aggressive promotion finally secured a $40 million investment from electronics giant Philips, which took a 27.5% stake in the new venture. Philips' involvement raised investor confidence, resulting in the private sector taking a 24.2% stake in TSMC. The government took the remaining 48.3%. TSMC formally opened for business in February 1987, and the VLSI fab facility located on ITRI's campus was rededicated as TSMC Fab No. 1. It is interesting to note that, like Taiwan's first demonstration plant, Fab No. 1, operated by TSMC, soon increased production efficiencies and achieved yields superior to Philips' own. TSMC grew to become the world's largest IC foundry services provider, with elder brother, UMC, expanding too into the world's third largest IC foundry. IC Foundry Services' success fostered a constellation of downstream packaging and testing firms, including Taiwan's ASE and SPIL, which have since emerged as the largest and third largest players in the global IC packaging industry. Also, the central kitchen business model, adopted by Taiwan's IC wafer foundries, provides fabrication services to chip design houses, slashing business costs while decreasing risks of design know-how theft. The IC foundry model offered an attractive, new approach for designers of IC chips, thereby stimulating a complete value chain that encourages entrepreneurship. ITRI's IC design specialists left to set up new companies, and Taiwanese entrepreneurs returned from the US. This created a vertically diversified model now familiar in the semiconductor sector. New semiconductor-related firms formed new industry clusters and turned the Hsinchu Science-Based Park into a high-density semiconductor fab of the world and a vital hub in today's cross-Pacific supply chain linking US and Taiwan-based IC design firms. Upstream mask technologies became increasingly important in the wake of Taiwan's semiconductor success. Precision mask capabilities are critical to the IC design process and to actual production.
所以市场上呢，这个国外本来在提供这种服务的公司就开始跑来看了，日本啊、美国都有企业都跑进来看，他们就已经慢慢在酝酿说，看起来是一个好的投资的时点。
Actually, Bing-Her Yang realized in 1976 while training at RCA that plans had overlooked mask-making capabilities.
但也可以把这个设计送到美国去啊，那么再把它做回来。不过这个东西就是你在整个的产业的技术里面就缺失一很重要的一块，就建议这个电子所把这一块把它建立完成。
In April 1979, ERSO opened a dedicated mask unit to develop comprehensive mask-making capabilities. The unit developed technical mask solutions for each stage of the IC production process until finally facing the spin-off decision in 1988.
所以当时我是非常快速的就去筹划这个台湾光照，就是说把那个时候台湾的瓶颈变成一个投资的机会。
Taiwan Mask Corporation, TMC, was founded on January 1st, 1989. dedicated to providing local IC design houses with professional mass production services. As such, it was able to reduce IC chip manufacturing costs and increase competitiveness. Launched in 1990, the Submicron project focused on developing memory design and process technologies. The project built Taiwan's first 8-inch wafer fab and inspired even more domestic and international talent to join the Taiwan IT industry. In 1994, Vanguard International Semiconductor Corporation was established as another spin-off from ITRI. Vanguard later merged with TSMC and has repositioned itself as a specialty IC chip foundry.
我想这个供应链的最重要的时代的一个意义，就是说，它是一个创新的引擎。这个供应链在这种所谓的高科技里面的这些产业，它扮演了一个火车头，而且做出了很多实际上成功的例子。所以，把台湾从70年代一直进入2000年的时候，这整个我们的社会经济的体制整个变掉了啊！从原来那么多的传统产业里面，现在变成一半都是高科技的行业。
The selfless contributions of the US-based Technical Advisory Committee and the innovative, determined spirit of the Industrial Technology Research Institute were critical to attracting those first recruits, averaging just 28 years of age at the time, to seed the foundations and develop Taiwan's semiconductor industry. ITRI offered young researchers an exceptional environment to create new horizons for themselves, for ITRI, and for Taiwan's high-tech sector, and, in the process, remade Taiwan into a global semiconductor powerhouse. ITRI was the greenhouse that nourished the seeds of Taiwan's semiconductor industry, as well as the progenitor of UMC, TSMC, TMC, and VIS. Farsighted government policies, overseas TAC consultant guidance, RCA-transferred CMOS technology, and Taiwan's first IC demonstration plant did more than create a new industry. They launched Taiwan into a new stratosphere of high-tech opportunities, fueled by private sector initiative and supported by science park technology clusters that today represent revenues in the billions of US dollars. Today, ITRI is creating leading-edge technologies in 3D IC packaging, nano and flexible electronics, micro-opto-mechanical electronics, 3D image processing, semiconductor optoelectronics, advanced display technology, and many more. These technologies ensure a dynamic digital experience and competitiveness for Taiwan's industries in the global marketplace. Taiwan's high-tech sector is following domestic IC technology innovations into a bright, sustainable future, very much its own.